Yeah, welcome everyone. After lunch, that's usually the most trickiest slot because everyone's like buried in the food coma, and hopefully you had enough coffee to actually get out of it again. It's also one of the reasons that I try to minimize the amount of slides I have and basically just like hack my way through the Spring Data examples and basically point out the stuff that we've added new. My name is Oliver Gierke. I work for Pivotal, as you're probably familiar with. I'm leading the Spring Data projects, which sort of means that everything that's not that's data related but not part of the core framework, things like JDBC or the core JPA and Hibernate support, that are still in the framework, but we have a set of umbrella projects. No, one umbrella project with a set of modules on top of that, and they basically take care of data access with relational databases on JPA, using a repository programming model, and also taking that into the NoSQL space and MongoDB, Neo4j, Cassandra, Couchbase, yada yada yada. There's a couple more. So, who of you has not seen Spring Data before? A couple of hands. Okay, I think I tried to make some comments on the way, but it's good to know because then I don't have to go into all of the fine grade details. If you've like used Spring Data before, you're probably aware of that we're using this release train notion to sort of combine a set of modules into a release train, which we basically name after computer scientists, more or less famous. And the ones that I want to talk about is the Hopper and the Gosling release. So maybe just to give you a bit of history on that talk, or how that talk actually even was incepted in the first place. We had this annual spring conference in the States, the Spring One conference, and we started with what's new in Spring Data, I think 2 or 3 years ago, and then turned it into a habit, basically repeating the talk, but looking at all the things that we've added in the last year since the very last conference. And it usually turns out that there's like 1 or 2 Spring Data releases per year. And like coming from the last Spring One conference, I'm not sure we had a What's New in Spring Data talk there, but just coming from that, I thought we'd have a look at some of the features that were introduced in the latest releases. So we named them like computer scientists. There's usually a milestone, a release candidate, and a GA release of that, followed by a couple of service releases while we're already starting developing the next release train. We've released Hopper, I think it's been a while ago, 6 weeks or something, alongside a service release, but that aside, so there's like the current maintenance, what you get with Spring Boot out of the box with the production Spring Boot 1.3.5, is it these days? I stopped counting, I'm always on milestones anyway. There's Gosling involved in there, so you get Gosling out of the box, but if you want to upgrade to Hopper, there's basically a single property in your build config that you have to change to Hopper-SR1 or SR2 coming up in a couple of weeks to get to that. So they should be compatible. There is a couple of gotchas this time for the Hopper release, which I'll be going into in the upcoming slides. But there's some. If you just use JPA, it should just work for you. But yeah, some other modules might be a bit more involved, the upgrade process. Dependencies. I mentioned those Spring Data release trains that prominently because we use them to not only implement new features, but also to raise our minimum required dependencies. And that's always a balance between we want to be sort of state of the art, like promote like the most recent releases of like the Java drivers of certain data stores, but also other software that we integrate with. On the other hand, we don't necessarily want to force you into an upgrade of some potentially hard to upgrade library just because you want to use a new Spring Data release. So, for example, the Spring Data JPA build is still running on Hibernate 3.6. Does someone even remember that version? Yeah, but we had we were thinking about going up to 4, but so far it's not problematic to drop to keep that compatibility. It still works with 4x. It still works with 5, with some gotchas due to some changes in Hibernate 5. But and the Spring Framework generation that we are built on Spring 4 still supports Hibernate 3, so that's why we stayed in there. So there's a bit of, speaking of which, Spring Framework generations, there's some interesting aspect here that I just wanted to briefly mention. If you look at the Spring Framework baseline versions that we had in the different release trains, we've always sort of been one generation behind. So when Spring 4.0 was just like the main version that was maintained in May 2014, Spring Data was requiring at least Spring 3.2. We still work, we're still forward compatible. We make sure that like even the 5.0 snapshots, that all that works for the current Spring Data releases. But we require a certain baseline version, and that's usually one framework version behind, just for exactly that reason that I just gave you, right? We don't want to force you to upgrade necessarily your Spring Framework version, although that shouldn't be a problem, admittedly, but we try to stay a bit behind there. We slightly changed that, and that's the first time actually in the history of the Spring Data umbrella projects. We're just released Hopper with the requirement to use Spring 4.2, which is sort of the current production version. That is sort of anticipating that Hopper is going to be in boot 1.4, which will then be on Spring 4.3, so that we're back to our usual pattern. Plus, it allowed us to take advantage of some of the new features that weren't easily doable with, let's say, using reflection or any of these tricks that we usually do to mitigate those API changes. But a very core theme of Spring 4.3, as Jürgen mentioned this morning, is the use of meta annotations and composable annotations, basically. And that requires us to use a bit of Spring 4.2 API and just to accommodate to that. So if you want to update to the latest and greatest, you need to be upgrading to 4.2. That's just basically it. We usually go ahead and maintain the former version for slightly longer time. So Hopper's or Gosling is going to be maintained slightly bit longer, also for the fact that it's still in Spring Boot 1.3, and that's the major version right now. So that be it. Okay. So aside the Spring Framework version, which should actually be the smallest problem or the smallest issue, there's a couple of major upgrades. We sort of have the problem of the umbrella project being so wide and supporting so many different databases that all these database vendors, of course, don't align their release schedules and not even thinking of aligning the release schedules of major versions, right? So we constantly have to deal with the fact that, oh, there might be a new major version of MongoDB out, and we might want to support this version, but does that make it a Spring Data 2.0? Well, probably not if everything else is staying the same. So there's some kind of, we've come to some, or let's phrase it this way, semantic versioning is a tricky thing for us. So we sort of weakened the constraints here. So we as long as the Spring Data user-facing API doesn't see any breaking changes, we still stay on that 1.something line, and we sort of give ourselves the freedom to break changes within the internal APIs, even from Gosling to Hopper and what have you. That means you actually get, or in this case, the Hopper is pretty special because we've introduced new major versions of individual modules in that release train, right? So there's no global major version that was flipped, but the Neo4j guys, and it was a similar model with the Couchbase guys. They basically rewrote their Spring Data module from scratch, called that a 4.0 or a 2.0 for Spring Data Couchbase, and then we took a step and let that mature slightly and reintegrate it for 1 or 2.1 respectively into the release train. So, and that's what I mean when I said, okay, it might be a bit more tricky if you want to upgrade to, let's say, your current Spring Boot application to Spring Data Hopper, and you use Spring Data Solr, for example, you will have to update your Solr, and you might have to adapt to some changes. In Elasticsearch 2.0, they just like removed some functionality. So if your application was happening to use that, then that's a bit of a problem. But we're sort of constantly torn between, okay, we still want to keep everything working, but at the same time we want to have support for the new versions. That said, support for Hibernate 5 is there, so in case you're using that. Hibernate 5 is a bit of a tricky issue as well because they changed a lot of the defaults. So if you're migrating an application, that could be an issue, but if you're starting from scratch with Hibernate 5, that should still work. As far as I know, Spring Boot 1.4 will ship Hibernate 5 by default, but you can downgrade to 4.x and will just continue to work. Similar story with the MongoDB driver. That was all in Gosling already. So if you're in Spring Boot 1.3, you should be set already. The last and final bit I wanted to mention is the Query DSL 4 upgrade. Anyone using Query DSL? A couple of guys. So they had a major release quite a while ago, and we were sort of wondering, can we support 3 and 4 in parallel? But it was kind of a weird thing to do and quite problematic. So we decided to just flip. So in case you're using Query DSL, you have to maybe change some package imports or something because they changed the namespace basically. All right, so in case you're not using Spring Boot and you use Spring Data, I highly recommend to check out the examples regarding the Spring release train BOM. It's basically a POM that you pull into your project, which will make sure that the individual versions are in matching versions. As you see, the Neo module is in 4, Couchbase is in 2, the JPA and MongoDB ones are still in 1.x, and you can easily get lost in these things. Boot solves that for you. If you can't use Boot, using the BOM will sort of solve that for you as well. There's an example project in there, but just for reference. Right? All right. So what did we do in Spring Data Commons? I'm going to show you some of the examples here, not in Spring Data Commons only, because they have to, these new features in there have to be implemented in a store module to sort of get activated for that store. But a lot of the infrastructure is available in the Commons module, and in fact, it basically opens up the possibility for other stores to pick up that functionality and actually make use of that. It's usually the core ones that we implement that functionality in the first place. So for example, we're going to see query by example functionality, and that's now available for JPA and Mongo in the Hopper release train, but we can definitely make it work for other stores as well. It's just that the core team at Pivotal, the entire release train is 15 modules, and I think we maintain 7 or 8 of these modules ourselves. The rest is community modules. So we don't really control the time these other guys have to invest, and we don't really want to make them do things just because we ask for it. But a lot of them will actually get into these features. There is Java 8 stream support on the repositories, and as I said, I'm going to spend a lot of time in the IE, which hopefully is sort of readable on that screen resolution. One of the things that so maybe for that one guy who hasn't seen Spring Data before, you basically declare a repository in interface. You extend a base repository with which you get some CRUD operations, and then you can define query methods on it that either get translated into a query. If you don't put anything here, then there's a naming convention that actually gets applied here, or you just define the query yourself. And there's a variety of things you can do. You can have pagination, you can return lists, you can return individual persons, and all of that stuff is going to be evaluated by the Spring Data infrastructure, and is actually just like executed once you invoke the method, right? There's a lot of stuff being done up front so that it's not done over and over again, like the query derivation and stuff, but the actual execution, of course, when you execute the method. So there's been a request that we support streams as return type, Java 8 streams. And with support, I don't mean execute the query, read everything into a list, and then call to stream on it, but rather like make the API or the underlying query execution use streaming facilities if they're available. And that's more tricky on some stores than it is on others. But just to give you an example what the effect of that actually is, I just chose the MongoDB sample here. As you see, we just like invoke the method. We need to do that in a try clause. So it's basically that try with resources from Java 7 so that the stream automatically gets closed when you're done iterating it. But let me just like execute that thing. And you see in the log output, if I scroll to that part, you see that we're reading data. So there's some, we insert some data and we're reading it. And you see that there is this, where was it? That, oh Jesus, that's gonna be a nightmare going forward. But anyway, you see we iterate over the stream, or we pull on the stream and call system out here. And if this was a list, we'd basically, okay, that I can just show you the example, the alternative to that. We would just read all the data. So we would read every document that's in the database, see here, on after load, on after convert. Every document is converted into an instance. We collect all of these instances, create a list from it, and then iterate over the list, and you see the output here. With the stream, it's different because we basically take the raw MongoDB cursor that we get back and wrap that into a stream so that the data is only read, marshaled, and basically returned when you pull on the stream. So you should see a difference in the log output here because now all of a sudden you see we convert the first document, we output it. And now that the iteration goes on, we take the second document and output it. So we don't have the need to allocate a huge list up front, right? Especially for larger result sets, that's kind of neat to have. With MongoDB, as I said, it's kind of easy to implement because it's like cursors all the way down. JPA is a bit more tricky because it's an entirely list-based API. So there's getResultList, which gives you a list with pre-populated APIs. But we're doing some kind of, not trick, but whenever we can detect which JPA persistence provider you use, we fall back to Hibernate specific API, Eclipse Link specific API, to actually use their streaming or their cursor APIs to provide you a stream the very same way. So we're not using the JPA API in that case anymore, but allow you to stream data out of the database here. So that's kind of neat to have. So it currently works for JPA and MongoDB. And yeah, I'm going to have to talk to the other guys. That's even been in Gosling, so that's already available if you're on boot 1.3.
Isn't it bad that you are actually exposing the stream from the repository? Because basically you are giving the user of the repository a power to do whatever operations with the stream.
Yeah, if you think that.
If you change the implementation of the repository, you are breaking.
So the question. Let me just answer the question. The question was, isn't it like bad to hand out the stream? I don't think it is, because I mean, if you don't want to use that, you can still use a list. But if the list becomes so huge that you get memory problems and you want to stream over that, then you just like use it. We are not exposing any database specifics here because it's just a stream, right? So it's just like, okay, some stream of data whenever that comes from a MongoDB or from a JPA or a relational table, that doesn't really matter here. So. Yeah, I mean, we're not forcing anyone into that. I mean, of course, we're still Java 6 compatible. That's probably something worth mentioning here, so that we auto adapt to Java 8, just like the Spring Framework does. Good segue actually into the support for completable future and listenable future. That just like ties or basically forwards what Spring Framework allows you to do anyway. There's like support. I think was it 4.1 or even 4.0 that added support for completable future in methods that are annotated with @async, so that are asynchronously executed, and you can just like use these return types in repository methods, so that the actual query is executed on a separate thread, and you can just like on complete and basically use the completable future API. That's also Java 8 basically. Listenable future is the Spring equivalent of the former. Got that. And yeah, the other thing, Java 8 specific, especially the mapping of JSR 3.10 date time types has been an issue with Hibernate generations before 5.0. So using those in JPA applications has required you to write a custom converter. JPA 2.1 converter, we just ship some out of the box. Which means that unless you're using Hibernate 5, you can use those, register those converters. So datetime API, and of course an equivalent for the 310 backport in case you want to use that on Java 6 already. Anyway, got that. Nope, that was one too hard. Query DSL web support. There's not been too many people, so I probably rather cut that short. Query DSL is basically an implementation, as the name suggests, a DSL to write queries, and so you get basically you get a type safe API to formulate predicates and criterias on and that's one of the cool features of Query DSL for both JPA, for MongoDB, and what have you. So it's some kind of unique programming model thing, which nicely fits the Spring Data approach, basically. So you get to execute those predicates by adding a Query DSL predicate executor interface to your repository, and then is there a test case even? There's not, because I need to start the application here. So you can use that programmatically. Actually, we can go through the controller and see how we call that limited screen state is kind of killing me. So you see we have some kind of predicate here. This is something that you would naturally what is it, queue person or something? No, pageable. What does it return? What's the type? Queue user it is in this case. So you'd go ahead in your code, say queue user, user, and then you get the ability to say, right, user.firstname dot ends with ignore case foo, right, and make that a predicate, right? That's much more usable than, let's say, the criteria API. It works on more stores, so it's kind of neat because you all get all this kind of compile time checks in case you rename properties and what have you. The thing was that we've got to request that, like from a web request, if I get a request, a search form basically, wouldn't it be cool if we could just from a request that was sent by sending a form like localhost 8080, just like a form here, there's some sample people in there in that I think it's even it's a Mongo database. So if I just send this form and say I type DO in here because I've seen Dora Adams from Winston-Salem, wherever that is, I would like to search for her, and I can do the request, and I get basically, in this case, I'm using some kind of like matching, basically equals or like ignore case. You see Dora, Dolores, and all those guys match here. And for the city, I think that's the way I set it up. Let's say I go with new. That doesn't work. No one from New York with DO. I think I need to do it this way. Okay. Yeah. So that's kind of, you see that it's sort of the same thing, but it uses a slightly different binding. So it's not ignore case basically, and it starts with. If I just go with Haven, I don't see that result anymore. So how does that work, and what do we need to do to actually get that to work? Actually, we don't have to do anything. We just define a Spring MVC controller method parameter taking a predicate. There's some smarts in there that might be able to resolve the type that you want to create the predicate for. Let's say if you return a HTTP, what is it, request response entity of user or something, then we find that. We can find the type out ourselves, but if not, you just declare it explicitly here, which then goes ahead and by default just binds all of the properties that user has from the request, and it applies some default bindings. So the default binding is, of course, just an equals comparison. If you want to tweak that, there's the easiest way is to just in this case, I'm using a default method here. You could create a Spring Bean of type Query DSL binder customizer. There's different ways to skin the cat here, but what it essentially allows you to do is to say, okay, for the city property of the address, I want to starts with binding, and for everything that's a string, I want to contains ignore case binding, right? Just like using lambdas in Java 8. That's kind of a neat thing to do. And you can also exclude properties and stuff like that. So you basically still have control over the way that things are bound, but you don't have to manually like look up the properties and create the bindings yourself. You get all this prepared into a predicate here. That's the support. Also part of Gosling already. Yada yada yada. Oh, it's DevTools starting through. No need for that. I'm sorry I get lost in this thing here. Okay. Got that. Web demo. Query by example. One of the big features that we shipped in Hopper, actually, we've got tons of requests for that. What we basically do, and I just like show you the code here, sort of user repository integration tests. Yeah, some deprecations because I need to get my Spring Boot code corrected. But the essence here is that we have this example value type here that you can just like hand in an instance of your domain type that's just like partially filled, right? So we just set the it's Walter White's, right? It's Breaking Bad here. Okay. So we want to find all the people that have a last name of White. So we can just like do that, and then either count them or find them, what have you. There's a query by example executor, just like you have the JPA specification executor and query DSL predicate executor. There's a new one for query by example where you can just like hand in the examples here. I don't need that one anymore. Nope. Nope. So that's the very trivial thing. It's kind of limited because there's a lot of questions coming up in terms of semantics. What does, for example, null mean? What if you want to search for a user that really has a first name not set, right? There's an additional overload here of that factory method where you can create a so-called example matcher, which allows you to specify like certain matchings for certain paths. So you can ignore path, you can customize a string matcher. There's quite a few things even for different properties with starts with and ignore case and yada yada yada. So you can get more complex about that. We're ignoring all collection properties and stuff like that. So it's really just like thought for maybe one-off query executions with sample objects. That's basically it. Even like with dedicated matching options. So you get a bit more complex here. Query by example, yeah, that's sort of it. Available for JPA and MongoDB as of Hopper. But I think there's other stores will pick this up as well because it's basically just like translating into a query expression by some predefined rules. So that's sort of it. Okay, an interesting thing on the query optimization side of things. Who of you has used Spring Data REST before? Couple of you. So in Spring Data REST, we have the notion of projections, which sort of means that it's basically just a framework that takes your repositories and creates or exposes HTTP resources for them, collection resource, item resource, what have you. And you very quickly get into a situation where you want to, like the structure of the representation you want to give sort of is not equivalent to what the entity actually looks like. So there's means to that where you can go ahead and say, okay, I have a customer projection. I want to basically sort of limit the data that I want to return in Spring Data REST in the HTTP case or in JSON then. But that's kind of a general pattern, right? So my entity looks some way by default, right? But my data access operation, my querying operation wants to either limit the data or I want to enrich the objects that I get back with additional data, what have you. So Spring Data REST has had that capability of just like declaring an interface with the data you want to expose, and by that sort of limiting the view on the data, but also being able to say, something like this, get full name, and then have an add value annotation here that takes a, what is it, a spell expression, what is it, hash this way, and you could just go ahead and say target dot first name plus, and then just like compute something on the fly, which I wouldn't recommend. Just for the sake of the example, you could, of course, I mean, you could compute the name like this if you want it. You could also go ahead and within here say at my Spring Bean method, and then hand the target to it. So rather than like having code in string, you just reduce that thing to a method invocation on a Spring Bean, and then have real code that actually does something with a target to calculate the result of the method. That was in Spring Data REST, that was applied on the HTTP or on the controller level. So we basically still read the customer instance and then put a proxy for that interface in front of the customer instance, and by that proxy or by that interface, we sort of shape the actual representation. So we were wondering, doesn't it make sense to actually push this even down to the repository level, so that like where you previously only could return, let's say, a find all method would always read all customers and all properties of the customers. What if I just like be interested in, like in this case, only the first names of the customers, right? Previously, I would have still have to read all the customer objects. Hibernate would still marshal the entire table into an object, read a lot of data. And what we basically now ship with Hopper is the ability to use those projections as return types on repository methods, which in the worst case will do the same thing as I just described, which means still read the customer instance, put the proxy in front of it, and just return that, right? But we can then go ahead from that default case, which is sort of nice because you don't have to do that thing manually outside and can actually let the infrastructure do it. We can be more smart about that and look at the customer projection in this case and realize it's what we call a close projection, which means there's no like dynamic lookups involved here. It's basically just like forwarding calls. So that we don't actually have to read the entire customer, but we can, by inspecting that projection interface, can find out which of the properties you actually only need to read, right? And in the case of JPA, we could then go ahead and basically turn this into the equivalent of like the equivalent of that u dot, let's say, first name from user u. That's basically it, right? So we basically use the return type to create the projection clause of the interface, and then by that basically optimize the query execution, and then take the result, still create a proxy for that thing, so that you don't have to deal with maps or anything, but rather can just call get first name and would get exactly, we have to use aliases here as first name. But you get the gist of it, I think. That works. That can be just used as a standard query. There is a customer summary. That's basically the thing that I wrote down. Anyway, coincidence. This is not a closed projection, an open projection, which means that we still read the entire customer, which will be available under the name target. That's just like the way spell works in this case. And you could just like, still get the entire instance and can do things with it. We can also use that. We can also use predefined or manually defined queries, as long as, the customer projection has this first name property, so we expect a first name thing to be part of the result, right? That's the projection interfaces. There's also the ability to use DTOs. So in case you already have existing DTOs, we can fill them up as well. So for this case, we would basically create a query that says select new customer DTO of, what was it, u.first name from user u, right? So we create the constructor expression for you. You don't need to do that manually anymore. And the most advanced feature actually is handing in the type at runtime. So while in this case that the return type or the projection is static basically, so when you call the method you always get that, but you could just go ahead and say, okay, I know I want to call get by first name, but I don't know what projection I'd like to see, right? So it might just change from call to call, and you can just go ahead and use that kind of declaration. And if you hand in an interface here, we will basically treat it like above, right? So we will see, okay, there's this interface. Is it a closed projection? Is it not? If it is, we can optimize the query. If not, we just like fall back to the default. If it's a DTO, we just like instantiate the DTO for you. And that again works for, I haven't really put it in here in the example, I probably should do that. That works for, pagination still works. It's just like a very nice, I think, addition to the query execution functionality here. So yeah, that's basically it. How much time do we have? 10 minutes only. What? How much is it? 250, right? 250 to 250? Okay. I just go on until someone throws something at me. That's fine. Okay, in Spring Data JPA, that was basically, yeah, I just like listed it here. Spring Data JPA basically gets all the things that you that I've just shown you from within Spring Data Commons. It's usually anyway our poster child project because it's by far the most used project at all. It's in comparison to other Spring projects. Spring Framework, of course, trumps everything. Then it's Spring Security, and then it's Spring Data JPA, basically, in terms of usage numbers. So that's all in there. In Spring Data MongoDB, there's a bit of other stuff that we ship with Gosling mostly. There is some SPI actually in Spring Data Commons again that allows you to contribute extensions for the spell to be used in query methods. So you can use spell expressions in query methods, which is very handy as Spring Security, for example. Spring Security, for example, hooks into that and allows you to basically express a query that says, give me all customers that were created by the current user, by the currently authenticated Spring Security user. And there's some SPI here so that you could hook into your own functionality into that. It was built with Spring Security in mind in the first place, but it's just like generally useful. MongoDB 3.0 driver compatibility. You've seen the Java 8 stream stuff, and there's execution of JavaScript function. That's just like nothing really fancy. That's a few of the new features of MongoDB 3.0 basically. Okay, Spring Data REST. I think because of the fact that we've like gone so far already, I won't show you the examples here. There's a lot of stuff in there. In case you haven't looked into it, if you're writing REST APIs and you're using Spring Data, I definitely recommend to look into it because it makes the implementation of RESTful APIs so much simpler. There's a lot of best practices built into the way that we structure the resources in the first place or by default, and it basically gives you a head start. There's usually always things that you have to tweak and customize because the defaults are just like defaults and are somewhat likely to not fit your use case. But it's a great head start. Just let me pick out some of the cool things here. Support for optimistic locking into e-tags, so that's basically us translating the version field into a corresponding e-tag with which allows you to do conditional gets and puts. That's what the slide should actually say. So you can basically say, oh, please update that customer only if it's still in that previous version. Things like that. Let me just like sort of finish off with before we go into the Outlook, do I have that prepared? Let me check. There is this kind of projections. No, I don't have it here. There should be. Spring Data REST. If I get it started quickly, there is the Hell browser is kind of interesting to see. Where is it? Does anyone make sense of that Eclipse sorting thing here? Well, anyway. Let me try that. It's kind of hard to find things here. So, we ship some kind of additional module of Spring Data REST that sort of adds or allows you to inspect the metadata that we expose on in the browser. So you have a REST API here. Oh, that's probably going to, no, it's there. So there's just like a Starbucks shop geolocation search API here. If I go to the console, I can just like http 8080/API, and then I should be able to. Not sure that's readable. Oh, it's readable in the back. So you get some REST API where you can just like explore stores and stuff like that. So that's what Spring Data REST gives you out of the box. But when you browse, when you point the browser to the API route, you get a HAL browser, which is basically the metadata format that we use, and it gives you like the response body, but it sort of understands the the media type, so HAL basically. So it sees that there is a stores link and a profile link, and it displays them here for you to browse and explore the API. And if you issue a GET request, you usually get just like this input where you can expand the HTTP parameters and what have you. And you would usually get a similar view, something like this, for post requests, where you just like send some JSON to create a new store, for example. But for that, the text field would basically look like this, because the HAL browser in itself doesn't know anything about the structure that the server is actually expecting. However, with Spring Data REST, we have quite some detailed understanding of what the payload actually looks like. And we expose that understanding in form of a JSON schema, which a tiny extension that we wrote to that HAL browser. That's not something we wrote actually, because it's from the creator of HAL in the first place. So Mike, what's his name? Mike. Don't know his last name. Anyway, it's not Mike Amundsen. Anyway, so we basically took his JavaScript application and slightly extended it to dynamically discover our metadata that we expose, so that we can then go ahead and take that JSON schema, hand that over to another JavaScript library, and basically get expose a. Does that work? It should. Just expose a form here instead of an empty. Yay! Broken. What is it? 409 conflict. That's great. Something to investigate. Anyway. Yeah, it's probably the new. I did a MongoDB upgrade, and it looks like there's some geospatial GeoJSON fuck up here. Anyway, so it basically presents the form for you, right? That's the key piece that we're shipping. The other thing is probably just the example broken. Anyway, that's it. There's in Ingles, in the not Ingles, in the Hopper release, there's quite some work has gone into teaching Spring Data Redis. Redis is the key value store, mostly used for caching, to teach it object mapping and repositories. So there is, and let me just briefly show you the code. Where do we go? Redis repositories. That's something that's new in that release, in the most recent release, and will effectively ship with boot 1.4. Is that you can now go ahead and it's quite extensively documented. You can have just a domain class here that has an identifier and some indexed fields, which we inspect. We expect those annotations and basically set up a structure with secondary indexes in Redis, so that whenever you store an object of type person into Redis, that we will make sure that the appropriate secondary indexes are created, which then allows you to go ahead and on these indexes formulate query methods, just like you're used to from Spring Data JPA and what have you. And we then perform the necessary lookup. So look up the secondary index first, find the actual objects that we have to return, and then return those. So you basically get repositories and object mapping for Redis. Alrighty. That's it. All right. Just that should be it for the let's like the flyover basically. 10,000 meter foot view on what's in there. I definitely suggest to check out the, where is it? Spring data examples. Yeah, which one is it? It's probably this one. GitHub.com, Spring data examples. There's like dedicated examples for all the different stores. You can just check it out, build them, run them. They're pretty extensively documented. If you find something you're missing, create a ticket, we fix that. To round things off, just to give you an outlook what we're planning with Ingles, what's going to become the next release train. We're looking forward to ship a milestone at least before Spring 1 this year, which will be early August in Las Vegas, in case anyone of you wants to like burn themselves at 40 degrees in August. Not sure that was a good idea to go there at that time. But we will have a milestone ready. The biggest item actually is to make Spring Data Cassandra a core module. We've got increased requests for support for that, and it's been previously maintained as a community project, which means the guys taking care of it unfortunately didn't have too much time to spend on it, and so it was kind of lacking behind features. It wasn't on the most recent Cassandra version, yada yada yada. So we're taking care of that. And have 2 people from our team like working on it, not full time, but just like spending time on it. We've also made, and that's actually already merged, looked into using method handles for property access. Especially in MongoDB, we spend a lot of time in like creating objects and setting values on objects. And there's already been some pretty clever code, I think, that was using ASM under the covers to generate some factory methods at runtime to avoid the cost of creating object instances via reflection. We got rid of that, and then we were looking into doing the same thing for property access. So instead of reflection set field, basically use Java 7 method handles to speed up that property access. And it's been, don't look at the code because ASM code always looks weird. But it sort of works, and it gave us like another 20%. The object instantiation gave us a 20% performance increase on the object mapping using property. The improved property access does so as well. So it's like basically about not spending too much time with stuff we don't want to spend time on. A bit of improvements on the MongoDB side. There is a prototype for inbound projections using JSON path. So basically, I've showed you the projections as outbound mechanism. So basically, shape responses. But we're also going to add some functionality that you can just declare an interface on the methods, have JSON path expressions, and by that consume parts of like a JSON response or something, which is kind of neat for the client side. It's sort of vaguely related to Spring Data, but it's some kind of a playground for us to inspect things that might end up in the core framework eventually. So if at all, 5.0, but we're going to ship it before in Spring Data just to get feedback from people. Incremental updates for Redis, and the Spring Data REST module is going to see a significant overhaul in terms of error reporting. There's like 2 RFCs, 2 specs out there that sort of standardize the way you would report errors in the REST world, and we're going to just implement support for them. It doesn't mean we're switched right now, but yeah, that's sort of it. All right. So yeah, as always, create tickets. Whenever you're stuck with something's not working, create tickets. Approach us, write us emails. There's like Gitter channels for Spring Data. I'll be here until Saturday morning, so in case you have questions, just come up. I've just like summarized I'm gonna upload the slides to someplace. Speaker Deck usually tweet that. Examples project. The wiki is kind of interesting in case you just want to. We have a dedicated wiki page for each release train where we list what's new in this release train. So it's kind of a curated changelog, basically. Not everything in there because it's usually like 1,000 tickets or something that we solve per release train, and not everything is like really a major thing. And if you're interested in release schedules, there's a subscriber calendar there. All right, so then, thank you very much. Let me just in case you want to take pictures. In case you have questions, as I said, come up, no problem at all, and enjoy the rest of the conference. Thank you.